Hello everyone. Today we are going to be looking at Cramer's rule, and this also helps us in solving a linear system of equations using totally the determinant way. Okay, so let's look at what is in Cramer's rule. Cramer's rule says if you have an invertible matrix of size n by n, then for any b in Rn, the unique solution of Ax equals b has entries given by xi equals determinant of a sub I b determinant of a. I goes from 1 to n. Now this determinant of ai sub b is the matrix which is obtained by replacing the entries in the jth column. Oh, sorry, the ith here. We're using the ith, yeah. The ith column by the entries given by the vector b. Okay, so I'm going to use with the help of an example how to explain this, so that you'll know what we are talking about. Okay, now solving this linear system, 5x1 plus 7x2 equals 3, 2x1 plus 4x2 equals to 1. The first thing you have to do is look at the coefficient matrix and the constant vector. The coefficient matrix is very important because if the determinant of this matrix is 0, then you know we are not going to have an invertible matrix, and hence we will not be able to get a solution. So it's important that the determinant is found out of the coefficient matrix. So let's look at the determinant of this, which is 20 minus 14, a 6. Clearly the determinant of this matrix of A is non-zero, and hence the matrix is invertible, and hence we definitely can find the solution to this linear system. So to find the x1, remember there are two variables, x1 and x2. To find x1, what we're going to do is we write determinant of a1 of b divided by determinant of a. Now determinant of a is already done. Now what is determinant of a1 of b? What this simply means is you look at the first column. The first column is 5 and 2. You replace this column by the constant vector 3 and 1. So you just write 3, 1, 7, 4, find the determinant, and you get what? 12 minus 7, 5. So the answer is the solution to this vector for x1 is 5/6. In a similar fashion, we can find the solution for x2. Okay, now remember for x2, what are we going to do? In x2, we are going to replace the second row. Remember, this is the second column, that's 7 and 4, by the constant vector 3 and 1. And we just find the determinant of this 2 by 2 matrix, which is 5 minus 6, or minus 1 over 6. So Cramer's rule is another way of finding a solution of the solution of a given linear system of equations, provided that the determinant of the coefficient matrix is non-zero. Okay. Now let's look, this was an easy 2 by 2. Let's look for a 3 by 3 matrix. Now in a 3 by 3 matrix, we have x1 plus 3x2 plus x3 equals minus 2, 2x1 plus 5x2 plus x3 minus 5, x1 plus 2x2 plus 3x3 equals 6. Now the coefficient matrix, basically remove the x1s, x2s and x3s and the pluses, just write down the elements here. The constant vector minus 2, 5 and minus 5, 6. Now for this to have a solution, this one, determinant of A should be non-zero. It would be a good practice for you guys to apply the properties and everything we have learned earlier and find the determinant. I will give you the answer. The determinant of this matrix A is minus 3. So clearly this is non-zero, and hence this matrix is invertible. So we just have to now go and plug in the values for finding x1, x2 and x3. Okay, let's start with x1 here. Now in x1, remember, what does it mean? It means for the top part in this fraction, determinant of a1 of b, we're going to replace the first column of the original coefficient matrix by the constant vector. That's what we're doing. Everything else, see, is exactly the same. The change is here. Notice this one, guys. This is where the change is happening. Minus 2, minus 5, 6 is one which is replacing 1, 2 and 1. So this will be a good practice for you guys to find the determinant of the top matrix. You find it will be coming to be -3. The answer is 1. Guys, please practice it. It is very, very important. Okay, now let's look at x2. Here what it says. x2 means you're replacing the second column. This is the one. So in other words, you're replacing this column, guys, by the constant vector, which is given by this. Okay, so you have, oh, sorry, guys, this should be 1, 2, 1. Mistake, guys, please. So it's going to be 1, 2, 1, -2, -5, 6, 1, 1, 3. Exactly, they should match. But that's where the change is. Yeah, you get 6 over -3. The answer is -2. Okay, the last one, guys, now. We are going to be looking at x3. Okay, so let's look at x3. Now, okay, so x3 is determinant a3. Now, look at this one. This is the last column, guys. 1, 1, 3. For the original coefficient matrix. Now, we're going to replace this by the constant vector, -2, -5, 6. And what are we going to do is find the determinant of this new matrix, which comes out to be -9. And the answer is +3, guys. Okay. So this is Cramer's rule, guys. Very easy. You just need to plug and chug and get the answers. Just remember what column is going to be switched. Very, very important over here. So I would recommend you guys to practice these questions given in the book 1 to 6. See you later then. Thank you.